matrices. So we're going to start off with scalar products. Okay, so if we look here, we're having this 2 times this matrix there. So all we need to do for scalar products is do the 2 times the individual element. So 2 times 9, 2 times 6, 2 times 4, 2 times 1. And if we simplify that, 18, 12, 8 and 2. So another one, let's do 3, 8, 6, 4, 1. 3 times 8, 3 times 6, 3 times 4, 3 times 1. Let's simplify that. 24, 18, 12 and 3. Okay, when you want to times matrices together, it gets much harder. Okay, so one thing you need to do first is check the order of each matrix. Okay, so this matrix has an order 2 by 2. This has an order of 2 by 1. So if we look at both these orders, so it'll be 2 times 2, we can see these two center numbers there are the same. So that means we can do it. And also, these two numbers on the outskirts represent the order of our matrix after we've times them. So when we times these two together, we'll get an order of 2 by 1. Okay, so when we want to times matrices together, we have to look at the row, then the column. So in this example, we look at this row, then this column. Then we need to do each individual element times the other one. So it would be 10 times 5 plus 3 times 2, as they're both in the same row and column. Then we need to look at the bottom, and obviously there is only one column, so we use this column still. So minus 2 times 5 plus 7 times 2. That equals 50. 6 minus 10, 14. 56, 4. And there we go. That is your final matrix. And it does have an order of 2 by 2, 2 by 1. So let's do another example. Okay, so if we look at this example now, they both have an order of 2 by 2, so we can do that. Then the final matrix will also be of an order 2 by 2. So we want to look at the first row and the second column. So 1 plus times 4, add that to 9 times 8. So that's the first element in our matrix. And we still want to look at the first row, but now we want to move on to the second column. So 1 times 6 plus 9 times 9. Then that's our second element of our matrix. Now we want to move on to our second row, as we have done all the columns for the first row. So 2 times 4 plus 8 times 8. We've now done the first column, so we can move on and do the final element. 2 times 6 plus 8 times 9. So if we simplify that, 4, 72, 6, 81, 8, 64, 12, and 72. So 4 plus 72, 76, 6 plus 81, 87, 8 plus 64, 72, 12 plus 72, 84. And there's our final matrix. Okay, so here's another example we can try together. And you might remember this matrix from the previous video, and we call this matrix an identity matrix. And this will have a special property when we times it to this. Okay, so let's start. So the first row, first column, 8 times 1, 9 times 0. Let's move on to the second column, 8 times 0, 9 times 1. Move on to the second row, first column, 1 times 1 plus 4 times 0. Let's move on. Second row, second column, 1 times 0, 4 times 1. Now let's simplify this. 8 times 8, so 8, that's 0, 0, 9, 1, 0, 0, 4. Then you might recognize that this matrix is the same as this matrix. So a matrix times the identity will give you the exact same matrix. Okay, so here's some examples you can go and try at home, and I'm going to walk through them now. Okay, so first we want to check if they can actually be times together. So we want to look at the orders. So this has a 3 by 2 order, and this one has a 2 by 2 order. So we can times them as these two numbers are equal, and it would produce us a 3 by 2 matrix. Okay, so we need to look at the first row, first column, 9 times 9 plus 1 times 2. Then we need to move on to the second column, so 9 times 1, 1 times 1. Okay, so we now need to move down to the second row times the first column. So 9 times 6, 2 times 2. And it's going to be the second column times the second row, 6 times 1, 2 times 1. Then let's move down to the final column, 8 times 9, 4 times 2. Then the third column times the second row, 8 times 1 plus 4 times 1. And now let's go and simplify this. So this is 81, 2, 54, 4, 72, 8, 9, 1, 6, 2, 8, 4. Okay, so that's 83, 54, 58, 72, 80, 10, 8, 12. And there's our final matrix. So let's move on to the second one. As you can see, these are both identity matrices, and they're both of the same order, so it will give us a 2 by 2 matrix, 1 times 1. And you don't really need to work this out, because you know any matrix times an identity matrix will just give you the exact same thing. So it's just going to be that. Now we can see we have this matrix and it's squared. So let's see what it gives us. So it's 2 by 2 matrix. Those numbers are the same, so we can times them, and it's going to give us a 2 by 2 matrix at the end. So let's just write it out in full so we can get a better understanding. Okay, so it's going to be the first column, second row, 81 plus 14. First column times second row. 18 plus 2. Let's move down. 7 times 9. 63. 1 times 7. 7. Move across. 7 times 2. 14. 1 times 1. 1. Simplify that. That is 95, 20, 17, 15. Okay, let's go to the final question. So this has a order of 2 by 3, and this has a 2 by 2. So if we look at these numbers down here, we can see these two numbers there are different, so we cannot do this multiplication.